Hello everyone, welcome to this new video. So in our previous videos we had discussed about two important concepts about module 1. One is related to Coulomb's law and for Coulomb's force of attraction, and we have seen the forces due to several charges, and we have seen with some of the problems as well. Okay, so in the last video I have told you about the concept of electric field intensity, right? So that we are going to discuss in this video today about what is electric field intensity due to a point charge, the forces which is released through that point charge, and what is the intensity provided by that force. Everything we are going to discuss in detail, and what is the relationship between electric field and force attracted due to the particular point charge. Okay, that everything we are going to discuss in this topic called as electric field intensity. Okay, so let us start now. So this is the basic pictorial representation of an electric field intensity, where they have demonstrated with one point charge Q1, and from that point charge the force is being released from the different directions. Okay, and from that point charge Q1 we are drawing one point charge Q2 in that same plane, just far from Q1, and we are joining them and giving naming this vector as R vector, which is moving from Q2 to Q1, and this is called as the position vector. Okay, so this is about the representation part. Let us see what is this electric field intensity now, the relationship between it. An electric field is a region where forces act. Okay, that we know, right? It is a region where forces act from all the directions. Let Q2, that is this point charge, be the positive test charge at a distance r, that is the position vector r, that is this distance is given as r from Q1. The resulting force per unit charge is called the EFI. Okay, the resulting force per unit charge. Okay, that is the definition of electric field intensity. That is, force per unit charge is called as electric field intensity, or it is denoted as EFI. Okay, so in this case, this is the unit charge. Okay, force attracted due to this unit charge. So that is electric field intensity E is equal to force per unit charge, that is in this case it is Q2, so F divided by Q2. Okay, so we already know the term what is F, that is from the Coulomb's force of attraction. We have seen that F is equal to Q1 Q2 divided by 4 pi epsilon into magnitude of R square into the unit vector R, right? So this is according to the Coulomb's force of attraction. This is divided by Q2. So one more Q2 term would be coming in the denominator part. Okay. So since here we have the product of charge magnitudes Q1, Q2, where already we have Q, it is divided by Q2. So Q2 would be getting cancelled. So we are left with electric field intensity E is equal to Q1 divided by 4 pi epsilon magnitude of R square into unit vector R vector. And it is given by the unit Newton per Coulomb. Okay, so this is basically the electric field intensity. So what are the changes you observe in the Coulomb's force of attraction and electric field intensity? In Coulomb's force of attraction we had product of charge magnitude, but whereas in case of electric field intensity it is given by force per unit charge, or you could be saying it as a single charge divided by the square of the magnitude between the force per unit charge into the unit vector R. Okay, where Q1 is the charge, R is the distance in meters. Okay, so since it is given in magnitude, so it is measured in meters. Okay, so this was about electric field intensity, and this is the basic formula which you could be writing for this electric field intensity. Okay, so now let us see electric field intensity due to several charges. Okay, that is, from this is one single point, and from that point we are drawing several point charges Q1, Q2, Q3, Q4 up to Qn. Okay, so what is the relationship obtained here? Just as we have seen the force due to several charges, right? The same way electric field intensity could be divided for several charges as well. Okay, yeah. So here we have Q1, Q2 up to Qn. It is all are touching towards this result point P, and all the unit vectors are, so all the position vectors are named as R1P, R2P up to RNP. Okay, and this P, where we are going to find the electric field intensity at point P, is given by E of P. Okay, and it is given by, first with respect to Q1, that is force per unit charge, that is Q1, Q2 would be getting cancelled, right? So we are left with Q1 according to the formula. See here, q1 divided by 4 pi epsilon, and here the magnitude is r1p, that is magnitude of r1p the whole square into unit vector r1p, plus for the second charge q2 divided by 4 pi epsilon, magnitude is r2p the whole square into the unit vector r2p, up to qn divided by 4 pi epsilon into magnitude of rnp the whole square into unit vector rnp. Okay, so this is the electric field intensity due to several charges, or in short we can write it as EP is equal to, so this could be replaced by E1. Okay, electric field intensity due to the first charge Q1, this is due to the charge Q2, and this is due to the charge Qn. So EP is given as in general E1 plus E2 plus E3 up to En. Okay, if the electric field intensity is calculated from one point to the several charges. Okay, so the total field at point P due to several charges is the vector sum of the individual component field at that point. That only we have discussed right now. Okay, yeah, where E1 is the EFI, that is electric field intensity due to charge Q1, E2 is EFI due to charge Q2, and En is EFI due to charge Qn. Okay, so this was about the complete electric field intensity concept. Okay, so pause the video and note it down if you want. So now we have a few problems for this EFI. So let us see that problems. I have already solved it and kept. I'm just going to explain it. Okay, yeah. This is the first problem. 2 point charges 20 nanocoulomb and minus 20 nanocoulomb are situated at 100 and 010 in free space. Okay, so this is the question given. We should be determining the EFI, that is electric field intensity, at point 001. Okay, they have given here at point P, that is this is the point P they have mentioned here. Okay, where the coordinates of this point P are P of XYZ are 001. So according to that, draw the pictorial representation here. I have drawn it. This is point P as P of 0,0,1, where from this point we are going to charge we are going to draw 2 point charges Q1 and Q2, where the values of this Q1 Q2 are mentioned as 20 and minus 20 nanocoulomb, and Q1 is situated at the points 100 and Q2 is 010, and from here Q1 to P you should be drawing one position vector R1P, Q2 to P you draw one position vector R2P. Okay, so let E1 be the EFI due to the charge Q1 as mentioned in the question, and let E2 be the EFI due to the charge Q2. Okay, now the total EFI according to the electric field intensity due to several point charges which I have discussed is given by E is equal to E1 plus E2, right, in this question. So here E is equal to, so what is E1? That is electric field intensity is force per unit charge, right? So here force is given as Q2 divided by 4 pi epsilon magnitude square into unit vector, where one unit charge would be getting cancelled here. So directly write the formula where this is E1 is the electric field intensity due to charge Q1. So Q1 divided by, so here it is mentioned as free space. So it is given epsilon value is equal to epsilon naught. Okay, so since it is free space, so Q1 divided by 4 pi epsilon naught into magnitude of R1P the whole square into unit vector R1P, plus electric field intensity due to charge Q2, that is Q2 divided by 4 pi epsilon naught again into magnitude of R2P the whole square into unit vector R2P. Okay, so this is the formula here for this question. Name it as equation 1. So in this, what and all are the terms which we need to find out? Just find it out. That is, first we need to find R1P, right? R1P is given by R1P is given by RP minus R1, right? So RP minus R1. So that is, what is RP here? RP here we have, here this is AX, AY, AZ, right? So this is 0 AX, 0 AY. So since the X and Y coordinates are 0, so you are left with only Z coordinates. So it is AZ vector minus R1, that is this Q1 coordinates, that is what we have 1 0 0 AX AY AZ. So AY AZ are 0, so we are left with only AX vector. So AZ minus AX is R1P. Okay, similarly we should be finding R2P also, right? So R2P is given by RP minus R2, that is again 0 0 1, that is AZ vector minus R2, that is here we have Y coordinate as 1, so AY vector. So R1P is AZ minus AX and R2P is AZ minus AY. Okay. Next, what you need to find the magnitude part. Magnitude of R1P. Magnitude of R1P is given by the coordinates, the coefficient square, that is 1 square plus minus 1 square. The coefficients of this part, here R1P, here we have 1 and here we have minus 1, right? For R2P also the same thing. So 1 square plus minus 1 square, that is 1 plus 1 is root 2. Similarly, R2P is also the same thing, root 2. Now, the unit vector R1P. Okay, the unit vector R1P is given by vector R1P divided by magnitude of vector R1P, right? Similarly, for R2P also the same thing. So, what is vector R1P here? AZ minus AX, right? AZ minus AX divided by the magnitude part. Magnitude is root 2. So, this is the unit vector R1P. Similarly, unit vector R2P is AZ minus AY divided by root 2. Okay, so these are the unit vectors. Now, these things we have found out. Now, just put it in the equation 1. That is, first we have 1 by 4 pi epsilon naught in both the cases. So, we know that 1 by 4 pi epsilon naught is given by 9 into 10 to the power 9, right? So, this is a standard value. So I have substituted that here in both these cases, that is 9 into 10 to the power 9. And here the charge value. For the first charge Q1 it is 20 nanocoulomb, and for here it is minus 20 nanocoulomb, right? Nano stands for 10 to the power minus 9. So 20 into 10 to the power minus 9 into 9 into 10 power 9 divided by 2. Okay, what is this divided by 2? This is actually magnitude square, right? Magnitude of R1P the whole square. So if you take root 2 the whole square, square and root would be getting cancelled, so we are left with 2 here, okay? Into the unit vector R1P, that is the same thing what I have mentioned here, unit vector R1P, I have written it here, okay? Similarly for here also, this 2 also is the root 2 the whole square, okay? So that's why we are getting 2 here. So here we have 10 to the power minus 9 and plus 9, so it is inverse of each other, so these two would be getting cancelled here in both the cases. So 20 into 9, that is 180. 180 divided by 2 is 90. So 90 by root 2 into minus AX plus AZ plus the same thing here. Here we have minus 90 by root 2 since we have minus here. So minus 90 by root 2 minus AY plus AZ. So 90 divided by root 2, if you calculate it, we will be getting around 63.63 into AZ minus AX. Then we have minus 63.63 into AZ minus AY. Okay, so multiply the terms. So we are getting minus 63.63 AX plus 63.63 AZ. Then we have minus plus 63.63 AY minus 63.63 AZ. So here plus and minus terms will be getting cancelled. So we are left with 63.63 AY minus 63.63 AX. So take 63.63 common outside. So we are left with the final answer as 63.63 into AY minus AX Newton per Coulomb. Okay, so this is our answer for electric field intensity. Okay, due to several point charges, in this case they have taken 2 point charges Q1 and Q2, where they have mentioned the values of the coordinates as well as the charge value. Okay, 20 nanocoulomb and minus 20 nanocoulomb. So this was one simple problem. Hope you understood this. This is very easy, guys. Okay, you no need to do much things here. Directly apply the formula, know what to calculate and execute it, and finally substitute in the equation and find the final answer. Okay, yeah. So let us see one more problem. Now here this one problem is based on same thing, but this time it is not 2 charges, but they have taken 4 charges, Q1, Q2, Q3, Q4 from the point P. Okay, yeah. So now for this, let us see what is the answer. The same thing, question is, find the EFI at point P of 1, 1, 1 caused by 4 identical 3 nanocoulomb charges. Identical means all the values of charges are same. Okay, that is Q1, Q2, Q3, Q4 all have the values 3 nanocoulomb. Okay, charges located at P of 1, 0, minus 1, 1, 0, 1, minus 1, minus 1, 0 and 1, minus 1, 0. Okay, so these are the 4 points where E1 is the EFI due to point P1, E2 is EFI due to point P2, E3 and E4 respectively. So our total EFI which we need to calculate is E is equal to E1 plus E2 plus E3 plus E4 substitute the values of E1, E2, E3, E4 according to the formula for electric field intensity. Okay, so I've written this equation here, so please go through this equation how you got it. I've explained in the previous problem, so I'm not going to explain it again. So just try to understand how we got this equation. Name it as equation 1. What are all the terms which we need to find here? R1p, R2p, R3p, R4p. Along with that, we need to be finding the unit vectors, right? So let's find that. First R1p, that is Rp minus R1. Okay, Rp is this point here. Rp is this point here where the coefficients are 1, 1, 1. So that's why it is Ax plus Ay plus Az minus R1. Here we have only X and Y. The Z coordinate is 0. So here minus of Ax plus Ay. Okay. So Ax into minus Ax. If you do Ax minus Ax gets cancelled. Ay minus Ay also gets cancelled. So we are left with only Az. Okay. So if R1p is Az, then you should be taking the magnitude of this R1p, that is coefficient square, that is square root of 1 square, that is 1 itself. So unit vector R1p is Az divided by 1, right? So that is also again Az. So this is the unit vector R1p. Similarly find for R2p, R3p as well as R4p. Okay, do that part. So I'll show it here. R2p is again Rp minus R2. Rp is Ax plus Ay plus Az. R2 is this time it is minus 1, 1, 0. So here X value is minus 1, Y is 1 and Z is 0. So the Z term is not there. Minus Ax plus Ay. Minus into minus is plus. Minus into plus is minus. So Ay term gets cancelled here. Ax plus Ax is 2Ax and we are left with Az here. So 2Ax plus Az is R2p. Take its magnitude, that is square root of 2 square plus 1 square. 2 square is 4, 1 square is 1, so 4 plus 1 5, that is root 5. So that is R2p is R2 unit vector R2p is given by R2p divided by magnitude, that is 2Ax plus Az divided by root 5. Okay. So similarly find for R3p the same thing, Rp minus R3. This is Rp and R3 this time it is minus 1, 0. So minus Ax minus Ay, minus minus plus, minus minus plus. So here no terms getting cancelled. Ax plus Ax is 2Ax, Ay plus Ay is 2Ay and Az. So take its magnitude, that is 2 square, square root of 2 square plus 1 square plus 2 square. That is 2 square is 4, 4 plus square root of 4 plus 4 plus 1. That is square root of 9. And square root of 9 is equal to 3, right? So now again find the unit vector R3p, that is this R3p divided by magnitude of R3p, that is 2Ax plus 2Ay plus Az divided by 3. Okay. Similarly for R4p, Rp minus R4, that is here this time it is 1, minus 1, 0. So X is 1, Y is minus 1, so Ax minus Ay. So if you multiply a minus term, so this would be minus Ax, so plus Ax and minus Ax gets cancelled. Ay plus Ay, minus minus is plus, right? So you would be getting plus Ay. Ay plus Ay is 2Ay plus Az. So again take the magnitude part, that is square root of 2 square plus 1 square, that is root 5. And this is the unit vector, that is 2Ay plus Az divided by root 5. Okay. So this like this we have got the necessary terms which we need to be putting in the equation. That you put it here. See here I have written it here step by step. Okay. This is for E1. E2, E3, this part is for E1, this is for E2, this is for E3, this is for E4. All have summed it up. Okay. Yeah. So I'm not going to repeat it again. Wherever we have 1 by 4 pi epsilon naught, that there I mentioned it as 9 into 10 power 9. Okay. And here all the charge values are 3 nanocoulombs. So that is 3 into 10 power minus 9. Okay. So here minus 9 plus 9 are inverse to each other. So all those terms have cancelled it here from all this set of terms. So here one by one I am just writing it here. 3 9s are 27. So 27 divided by 1 is 27 itself. So here we have 27 A cap Z. Okay. So here what we have, 3 9s are 27 divided by 5 into root 5. That is 5 root 5. 27 divided by 5 root 5. I have simplified it and I have got it as 2.414. Okay, 2.414 into 2Ax plus Az. And here in the last term what we are having, 3 9s are 27, so here 9 gets cancelled, so we are left with only 3. Okay. Also here we have 3, so here 3 and 3 gets cancelled. Okay, so we are left with only this term again, the same term, that is 2ax plus 2ay plus az. Okay, plus again 3 9s are 27 divided by 5 root 5 again, that is again 2.414 into 2ay plus az. Okay, so solve this. 27 az multiply 2.414, so we are getting here 4.828 ax plus 2.414 az. Then here we have the same term again, so I had made a mistake here, so this term again you write it as it is, 2ax plus 2ay plus az. Then again 2.414 into 2, that is plus 4.828 ay plus 2.414 az. Okay, so now we have 4.828 ax and here we have 2ax, so that would be 6 plus 6.828 ax. Then we have 4.828 ay plus 2ay, that is plus 6.828 ay. Then we have 2.414 az plus 2.414 az plus 27 az. After summing all of them, you would be getting approximately as 33.665 az. Okay, so that I have written it here after adding all of them. So our final answer is this here. Electric field intensity E is 6.828 is common here, so take it outside, into ax plus ay plus 33.665 az Newton per Coulomb. Okay, so this is our final answer here. So hope you understood this problem very carefully, and this was about electric field intensity and how it is calculated for a single point charge and due to several point charges. Everything I've discussed. Okay, so one problem from this also they would be asking for sure. Okay, for internals as well as exam point of view, final exam point of view. Okay, so please go through these videos regularly, try to understand it, watch the videos till the end, like, share, subscribe to our channel, be updated because we are going to provide these kind of videos regularly. Also, I've uploaded the rest of the modules, module 2, 3, 4, 5, all the videos. Go and check it out, it is available in the playlist. Okay, so that's all for this video guys. We'll see you in the next video with the other concept from module 1. Thank you.